The universe is a vast, silent place, full of mysteries that stretch the very limits of our imagination. For centuries, we've looked to the stars and asked the same questions. Are we alone? What's out there? We built telescopes, incredible instruments of power, to try and peel back that cosmic darkness and find some answers. And now, the most powerful telescope ever created, the James Webb Space Telescope, has aimed its golden eye at our closest stellar neighbor, the Alpha Centauri system. For years, we've wondered what secrets it held. Now, we might be on the verge of finding out. The James Webb Space Telescope has sent back data from the system, and it hints at something astronomers never thought possible ever even. Something that challenges our fundamental understanding of how planets are made. Scientists are looking at strong evidence of a discovery that, by all accounts, shouldn't exist. Deep within the glare of a star almost identical to our own sun, Webb has found new hints of a massive gas giant planet in a place our best theories said was impossible. This isn't just another potential planet. This is a candidate that could rewrite everything we know about how solar systems are born. To understand why this is so stunning, we first need to get to know the target. The Alpha Centauri system is our next-door neighbor in the grand scheme of things. Located just over 4 light-years away, it's so close that if our solar system were a house in New York City, Alpha Centauri would be just across the street in Philadelphia. It's a system we've studied for centuries, a bright beacon in the southern sky. But it's not a simple setup like our own. Alpha Centauri is a complex and chaotic dance of 3 separate stars. First, you have the main event Alpha Centauri A and Alpha Centauri B. These 2 stars are locked in a gravitational hug, orbiting each other once every 80 years. Alpha Centauri A is the real prize. It's a G-type star, almost a twin to our sun in size, temperature, and color. Its companion, Alpha Centauri B, is a little smaller and cooler, more of an orange K-type star. Their orbit is immense. At their furthest, they are separated by a distance comparable to how far Pluto is from our sun. And at their closest, they are about as far apart as Saturn is from our sun. Then, way off in the distance, is the third member of this cosmic family, Proxima Centauri. It's a tiny, faint red dwarf, barely clinging to the gravitational influence of the main pair. We've known for a while that Proxima Centauri hosts its own planets, but the grand prize has always been the sun-like stars, A and B. Finding an Earth-like planet around a sun-like star right next door is the holy grail of astronomy. For decades, however, finding any planets around Alpha Centauri A and B has been an exercise in frustration. The problem is simple: stars are bright. Incredibly, blindingly bright. Trying to spot a dim planet orbiting right next to one is like trying to find a firefly next to a stadium floodlight from miles away. The star's glare just washes everything out. Beyond the technical challenges, there was a huge theoretical problem. Our understanding of how planets form suggested that systems like Alpha Centauri were simply too violent to host large planets. The constant gravitational push and pull between the 2 main stars should act like a cosmic wrecking ball and would disrupt the delicate disk of gas and dust where planets are born, either flinging the material out into space or stopping it from ever clumping together. Because of this egg beater effect, most scientists predicted that if we found anything, it would be small, rocky worlds that formed fast. A giant planet, a gas-filled behemoth like Jupiter, was considered almost impossible. It was a rule we thought we understood, and that rule is now on the verge of being broken. And then, a new eye opened on the cosmos, the James Webb Space Telescope. Launched in 2021, the JWST is an engineering marvel designed to see the universe in infrared, the spectrum of light that lets it peer through dust and see the faint heat of ancient stars and newborn planets. And in August of 2024, it turned its powerful gaze towards Alpha Centauri A. To overcome the star's blinding glare, astronomers used one of Webb's most clever tools, the Mid-Infrared Instrument, or MIRI, and its built-in coronagraph. A coronagraph is basically a high-tech version of holding your hand up to block the sun. It's a tiny, precisely engineered mask inside the telescope that blocks the light from the central star, creating an artificial eclipse. In that manufactured darkness, the faint, reflected light of anything orbiting the star might just pop into view. As the data from Webb streamed back to Earth, scientists began the painstaking process of analysis. They were hunting for a ghost, a signal thousands of times fainter than the star it orbited. And then, they found it. Tucked away in the darkness created by the MIRI coronagraph was a faint point of light. It was an object around 10,000 times dimmer than Alpha Centauri A, located at a distance of about 2 astronomical units, or twice the distance from the Earth to our Sun. This wasn't just a random background star. Rigorous tests and advanced image processing helped ensure it wasn't an instrument glitch or a distant galaxy. The light signature was consistent with that of a giant planet. The faint glimmer wasn't a star, it was a candidate for a new world. This hint of a massive, gaseous world orbiting our nearest sun-like neighbor, built upon a tentative candidate spotted by the Very Large Telescope back in 2021, making the case stronger than ever. The possibility was shocking, and it felt very real. Just as scientists were grappling with this impossible planet, the story took another dramatic turn. Eager to confirm the finding, astronomers scheduled follow-up observations with Webb in February and April of 2025. They pointed the telescope back at Alpha Centauri A, blocked the starlight, and looked for the planet, and they saw nothing. The candidate had vanished. The immediate fear was that the original detection was a fluke, some kind of temporary glitch or a background object. But the truth might be far more interesting. The leading theory is that this isn't a case of a disappearing planet, but a planet playing a game of cosmic hide and seek. It's likely on a highly eccentric, or oval-shaped, orbit. This means it swings in very close to its star for part of its year, and then swings far out. During those follow-up observations, it's believed the planet was in a part of its orbit that took it too close to the star from our point of view, hiding it in the glare behind the Coronagraph mask. It wasn't gone, it was just hidden. In fact, scientists who published their findings in the Astrophysical Journal Letters ran the numbers. They found about a 52% chance that a planet with this proposed orbit would have been undetectable during those specific observation windows. So, not seeing it doesn't debunk the finding. It actually adds evidence that this is a world on a wild, eccentric path, exactly the kind of chaotic orbit you might expect for a planet that grew up in such a turbulent system. While Alpha Centauri might host this surprising giant, its distant, smaller sibling, Proxima Centauri, tells a very different, much harsher story. This contrast paints a vivid picture of just how diverse planetary systems can be, even within the same family. We've known for years that Proxima Centauri has at least one planet, Proxima b, a super-Earth that orbits in its star's habitable zone, the region where liquid water could theoretically exist. On paper, that sounds amazing. In reality, Proxima b is likely a world locked in a planetary nightmare, because it orbits so close to its small star. Its year lasts only 11 Earth days, and it's almost certainly tidally locked. The same side of the planet forever faces the star, while the other is locked in eternal darkness. This creates a world of extremes, one side scorched, the other frozen. Any hope for life would be confined to a thin twilight ring between them, but the real killer is the star itself. Proxima Centauri is a volatile red dwarf that unleashes ferocious stellar flares, which can be hundreds of times more powerful than the Sun's. This stellar fury would have relentlessly sandblasted the planet, likely stripping away any protective atmosphere and boiling off any oceans it might have had. Recent data seems to reinforce this grim picture, showing no signs of a substantial atmosphere. The dream of a habitable world at Proxima Centauri is likely just a dream. The juxtaposition is stark. One star in the system, Proxima, appears to have sterilized its planets. The other, Alpha Centauri A, has somehow nurtured a giant candidate that our theories say shouldn't even exist. This tale of two systems highlights the complex dance of forces that governs the birth of planets. So, what does this all really mean? The gas giant candidate at Alpha Centauri A is more than just another dot in the exoplanet catalog. Its possible existence is a direct assault on our established theories. It's a beautiful, inconvenient fact that forces us to question what we thought we knew. This finding throws the doors open to a sea of new questions. If our models are so wrong about our closest neighbor, where else are they wrong? Could gas giants be common in binary star systems, a possibility we had largely dismissed? This single candidate has transformed binary systems from planetary graveyards into promising new hunting grounds. If confirmed, this world, known as Candidate C1/S1, will be a landmark in astronomy. It will be the closest exoplanet to a sun-like star ever to be directly imaged. It will no longer be a wobble in a dataset. It will be a tangible place, a cosmic laboratory on our doorstep. We could study its atmosphere, climate, and composition in stunning detail. The journey to confirm its existence is the next great chapter. More observation time with Webb is crucial to catch the planet when it has moved further out in its orbit, away from the star's glare. And Webb isn't alone. Future observatories, like the Nancy Grace Roman Space Telescope, set to launch by May 2027, will bring new capabilities online, potentially finding even more worlds like this one. For so long, we looked to Alpha Centauri with expectations shaped by our own solar system. We hoped for another Earth orbiting another sun. We expected to find small, rocky worlds or nothing at all. Instead, the universe has delivered a profound hint of a surprise. It has shown us a glimpse of something colossal, something magnificent and unexpected that defies our neat and tidy explanations. This isn't just about one potential planet. It's a fundamental shift in our perspective. It's a humbling reminder that the cosmos is far stranger and more surprising than we have ever imagined. We are standing at the edge of a new frontier, one that begins not in a distant galaxy, but in the star system right next door. The James Webb Space Telescope has opened a door, and we have only just begun to peek through it. The story of Alpha Centauri, the neighbor we thought we knew, is only just beginning. What do you think this incredible find means? Could there really be a giant planet orbiting our closest solar neighbor? Let us know your theories in the comments below. And if you want to stay on the cutting edge of what humanity is discovering in the final frontier, make sure to subscribe and hit that notification bell so you don't miss our next journey into the unknown.